Hello, everyone. Welcome to another binary episode of the Day Zero podcast. I'm Spectre. With me is Z. As always, we'll start with the spot the Vuln solution, which I'll let Z get into.
Yeah, and this week's Spot the Vuln is actually, so if you want kind of more in-depth explanation, I do talk about this on yesterday's episode because this code was taken directly from our EarnHub topic. Uh, this code was live on the blockchain and used to steal close to 300, well, in terms of valuation, roughly a little under 300,000 US dollars worth of whatever token. And the issue ends up being the fact that the token pool. So the idea of this make hop is that users go, they buy shares, whatever, and they're able to earn rewards by keeping them in there. And this make hop function, you can call that and move your shares to another pool that implements their ice staking interface. So that can be any pool you want. As long as it implements that, this should work out. But what it does is on line 13, this code will call the dot approve, which is basically saying, approve this contract address, so the address of the new pool, to make a transfer of up to whatever value it gives. And the value that it decides to give isn't the amount that isn't like the amount of shares that they have, or isn't based on like a token to amount translation or anything. All it's based on is how many tokens are in the pool itself. It gives approval for the entire token supply to be transferred out. So a malicious pool could take that approval, they get called on receive hop, and then transfer all of the tokens away rather than just the amount that they're supposed to transfer away. So kind of a really stupid and simple issue in this case. Literally just malicious pool takes all the coins because they allow it to happen.
Yeah, and like I said on yesterday's episode, one of those things where it might not be super obvious if you're not familiar with smart contract code, but if you are, then yeah, this seems like something that would be fairly blatant and quite
Yeah,
a
I mean
big screw up to let
it
through.
it really just takes realizing like that dot approve is for the entire supply. Like that's the main thing that would at least pique my interest looking at this, is the fact that it's approving a transfer of the total supply. That would kind of get my interest. Of course, if there was some limitation on who could implement ice staking and some other challenges there, then fair. Like there are some things that maybe could be done, but that approval definitely kind of just piques my interest and is what I'd probably take notice of first.
All right, so with that said, we'll get into some of the topics for today. We'll start off with a quick news topic out of Google. You may recall on a recent episode when we talked about a Linux kernel bug, we mentioned the Google kCTF VRP that they were running, where they were paying some big bounty payouts for vulnerabilities, assuming they could be exploited on their Kubernetes container. And at the time we said, like, sadly that program was over. It technically expired on the 31st of January, but they just announced yesterday that they've extended it to the end of the year. They have implemented some changes as well. I believe I think before they were paying for duplicate submissions for 0 days. They're not doing that anymore. They're only paying for the first 0 day. After that, they pay $0. I think they tweaked the payouts a little bit as well, and they've put some bonuses. There's a bunch of like details here if you're interested in that. I mainly just wanted to shout out the fact that it has been extended like this to the end of the year. To my knowledge, this hasn't really I haven't really seen this done before with any of the previous Google VRPs, but where this is the Linux kernel and where they saw some success, I think they mentioned they got like yeah, 9 submissions. So their VRP was very successful. So I guess with that in mind, they decided they wanted to extend that, and yeah, so Linux kernel is still a great target if you want to look for things and get some decent payouts from Google.
Yeah, these definitely are fairly decent payouts and bonuses on the exploit development side, such as like they do offer the 20,000 bonus just for using a novel exploit technique, where basically using a previously unknown object as a way of transforming one of your primitives. those little things make this actually pretty appealing, just from the exploit dev side of things, not even from the hunting. Just like finding new techniques, and they're going to pay out for that information, which I haven't really seen other bounties doing at all.
Yeah, there's a lot of different avenues you can go here, and kind of explore. So yeah, very cool program by Google that's running, and I'd encourage people to check it out if they're looking for something to do. All right, so we'll get into a research topic next by ZDI. Unlike most of the time, where pretty much any time we cover ZDI, it's going to be like a vulnerability report. This is a bit more of a breakdown of the use of taint analysis. In this case, on MySQL cluster, after a bunch of low-hanging fruit bugs were discovered. Basically, what they were thinking is we've received a bunch of these reports in this very buggy-looking attack surface. I think they mentioned it being the open port for the management node and the data nodes. And they were thinking, like, how can we kill a bunch of these bugs quickly? The leap that most go to at that point is fuzzing. But they said they didn't really want to deal with fuzzing's limitations when it came to certain bug types and deal with coverage. So they decided to go with static analysis and taint analysis. Um, and they looked at two different tools for doing that, Clang Static Analyzer as well as CodeQL, and they kind of do a bit of a comparison between the two and try to highlight the best of both. So there's a lot of really good information in here on both tools and just taint analysis in general.
Yeah, before
The
you
type,
jump into that, sorry, I do also want
yeah,
to shout out like the couple types of issues. They are only really looking for like using taint analysis on these low hanging fruit bugs. Like the one that they show as an example here grabs a pointer and ultimately uses that pointer without any checking here in this dot set, which just use it as like an array index. So just looking for that really simple, like easy to define source, easy to define sink, and low hanging bugs in that sense. I did just want to call out that sort of issue. The other one they do are like mem copies overflowing, but or like having control over the size of the copy, basically looking for it to sync into there. So I want to show it. Those are the two things that they're looking for through all of this taint analysis. It's not super complex bugs.
yeah, just linear overflows and out of bounds accesses. So, yeah, like Z said, what they were gunning for there was those low hanging fruit type bugs. And they talk a little bit about how taint analysis works. Z just kind of touched on some of those terms there, but there's four important terms that they define before they go too much into it. Being a source, which, as it sounds like, is just a source of data. A sink, being some piece of code that does something potentially dangerous, like an array access or a memcopy call. Propagation, which is the data flow, which parts of the user data can influence a particular value that could be going to that sink. And then finally, a sanitizer, which indicates whether or not the data is validated, which you kind of define as a pattern. So by defining what the source, sink, propagation, and sanitizer should look like for an input, you can model it and find areas that kind of violate the like assumption of having a proper sanitizer, for example. Um, so yeah, as I mentioned before, they're looking at both Clang Static Analyzer and CodeQL here. Both have different advantages and disadvantages. For example, Clang Static Analyzer will have a set of predefined source and propagation values, as well as a default sink for some of the more common stuff like format string issues, memcopy size. You can also define some simple values fairly easily with a config file, but if you want to do more complex sources and sinks, you need to write a CSA checker, which I'm assuming is like the pass or plugin system for the Clang Static Analyzer. Um, and yeah, to make it easier there, they modified the target code base to take a predefined static value for a source to make them more easily identifiable, which I wanted to call out because that was kind of a cool trick.
Yeah, I
Um,
thought that was a really fun, like it's very much a hacky way of going about doing this sort of taint analysis. Um but yeah, basically they just end up swapping out anywhere that it's user controlled or that they want to care about. They swapped out whatever code was there and just told it to use get environment CDI. Um Stupid trick, but it's effective because in this case, like when you're doing static analysis, and in this case with the taint analysis, it doesn't need to run the code. It just needs to analyze the code. So, doing something like this isn't going to run to get like a pointer value or the size out of the environment and have them be the same and all of that. but it's going to work just fine for actually just tracking where does this source go and what does it flow into. So I mean, out of chat 6A asks, should I use this on my code to prevent bugs? You shouldn't replace all of your sources with Git environment. That probably won't help you. But using taint analysis, I'm not sure really about. I mean, yes, you can prevent bugs in terms of, like, implementing in like the CI/CD sort of setup. But I feel like there are other things you should be doing over just taint analysis. Taint analysis really feels like to me something that the research, like, that's more on the research side. I'm coming in to look this, saying I'm going to define my source instincts. But I mean, if you want just a quick check, it can be there, but you are going to get, in some cases, false positives because it doesn't know, out of chat also. Yes, fuzzing absolutely should be part of just that standard software development lifecycle. You develop, you fuzzing's just part of it. Let that find bugs, because that doesn't really need to be guided or take much work. It just finds issues and then it takes work. Whereas taint analysis, you kind of have to do work up front. The other thing is a lot of the default results that you're going to get out of taint analysis may not actually be vulnerabilities. They talk about it a little bit where the CodeQL example they use ends up having some cases that basically weren't issues because it used like basically a check value function that just kind of passed through. So you would need to define your taint analysis to actually find all of those. So you'll get like false positives if you're just running this. A lot of static analysis tooling takes a lot of tweaking to get it right. A good, mature, like, security process at a company, they can stand this up and tweak it for ideally all of their code bases and take that time to do it, but it is something that's hard to do without getting just a ton of false positives and things that don't matter. So while it would be ideal to have it running during like your development process, just so it catches those things if you accidentally introduce it, and that's definitely not a bad idea, I can imagine that just being very overwhelming until you actually take the time to um, work out all of those false positives that may come up. Normally, I'm kind of thinking about this more as just the researcher comes on and they're going to spend the time looking at, the results that come up. It's a lot louder and a lot noisier, or can be noisier, than something like fuzzing, which if it crashes, you've got a crash for sure. Like, it's definitely able to hit it.
Yeah, I mean that's the thing. Fuzzing is going to have a lot less overhead. So, in terms of priority on the development side of things, I think fuzzing probably makes more sense than SaaS tooling. That said, SaaS tooling definitely has a place. Like you mentioned, it's kind of, we're seeing more and more uptake in it being integrated into CI/CD stuff. So,
Yeah,
yeah,
like, there are places for it, like taint analysis in particular, maybe not. Semgrep is a great choice, I think, if you want to get some of this sort of analysis, just making sure like sanitizer functions are called. You could do that using like semgrep, which would be kind of really easy to write the rules for versus stack analysis. Yeah, or for taint analysis, like, that doesn't really give you as much taint analysis as you might like. Um, I mean, because static analysis has its place for sure as part of CI/CD, and like in that common runtime, it's just, I feel like it's a later step in kind of that maturing process.
so getting back a bit to the CodeQL and Clang Static Analyzer differences, what I was basically highlighting there was with Clang Static Analyzer, you kind of get more stuff for free with like predefined source and propagation values, and it's easy to implement some simpler stuff. But whenever you want to do more complex taint analysis, it's harder to do because you have to write like a custom plugin for it in C++ or whatever. Looking at the other side of the coin with CodeQL, they don't have any predefined sources or sinks. You have to go out of your way to define them. And
That's not
even for,
exactly true, actually.
so
CodeQL,
there
their
are
default,
libraries.
yes, their default library can include things, especially on some common frameworks that you can just import and use. But yeah, you do kind of need to at least be aware of that in order to get the full benefit. And it's mostly just around some of the more popular things.
Yeah, it's not really provided out of the box in the same way. Um, and the other thing is too for CodeQL, even for some of the more basic type of queries that might be easier with Clang Static Analyzer with their config file, it is a little bit more effort to write the definitions for. Um, but on the other hand, it's probably easier to write more complex sources and sinks in CodeQL because of how flexible it is. So you wouldn't have to go out of your way to write like a separate plugin or pass. So CodeQL kind of has that double-edged sword of being both really powerful and giving you a lot of capability, which means that it does have a bit of a steeper learning curve, but you can do more with it um, faster, I think. So yeah, it also has some stuff already for propagation. They did find that it missed some cases, so they had to write some like an additional taint step function to check like structure field accesses. I think they said were getting missed somewhat often. So they had to write a definition to get those counted. But yeah, CodeQL in general takes a little bit more work to set up, but it did end up being more effective in the end, which was kind of expected. Because in the end, they found 37 bugs, 28 of which were new, 9 overlapped with previously reported issues to ZDI. The Clang Static Analyzer found 28, meanwhile, CodeQL found 34. So, I mean, both setups did pretty well here. CodeQL found a bit more, but it also took a bit more work to set up. So, yeah, it kind of makes sense, and there's trade offs there, obviously.
Yeah, I mean, I've shilled CodeQL before. I'm a fan of CodeQL myself, as using it as part of that like researcher in the loop type of assessment where you're controlling and just looking up pieces of information and doing this taint analysis. Like it's built in there, it's nice. Also does just like data flow analysis, which is slightly different from taint. Taint being, well, if it impacts the value at all, versus data flow being this exact value needs to flow through. Kind of a subtle difference, but it does have those options there depending on what you're actually looking for that can kind of matter too. I mean, I'm a fan of CodeQL. I haven't played around as much with Clang Static Analyzer. I've done more on the interpreting the LLVM that Clang can be set to output and then interpreting that to do analysis passes. I haven't actually played around with the static analyzer itself.
Yeah, I'm in the same boat. I do want to check it out a little bit, though, after reading this post.
Out
Um,
of chat, Oma Heath asked, did they discuss that these bugs were all true bugs, i.e. no false positives? Yes. So they do call that they generate proof of concept manually to confirm each bug. So this is after they reviewed all of their reports, because they have initially like 320 reports. If you run CodeQL, it'll find like all of the different data flows. So like there's an if and an else statement and it still flows after it or something. You'll end up having like two reports for it because it's two different data flow paths. So it gives some duplicates there. But yeah, ultimately these came down to just being um the 37 unique bugs.
and that's good that you brought that up, to be fair, because we touched on it briefly earlier, but yeah, they do talk about how they had to go through all of these reports to find like the valid ones, and that is one of the trade-offs you have between static analysis and buzzing is that you have that overhead of having to cut out the false positives and go through the cruft, which isn't exactly fun. But I mean, with fuzzing, you kind of have it too with triaging, but it's in a different part of the pipeline, I guess.
Yeah, you have
Um,
it after you have an issue that fuzzing's discovered. Then you're looking into how it happened. Whereas this is it feels a little bit more overhead on the front end rather than fuzzing feels like the overhead's on the back end.
yeah, for sure. But yeah, I mean, the main point of this post is just to show how powerful static analysis can be for finding certain types of bugs, especially some of those like lower hanging fruit ones that don't require super complex queries to find, and how you don't necessarily need fuzzing to get results. Though like we've kind of said before, ideally you would have both running, like fuzzing and SAS tooling, from like a development angle. But also, like we mentioned earlier, uh, there is a bit more overhead on setting up the SAS tooling, and you can kind of see that in this blog post. They go through defining those sources and things and stuff. So yeah, I found this to be a really inspirational post. I think it's one of the best CDI posts that we've covered, honestly. So I encourage anyone interested in VR to check it out because there's definitely stuff to be learned here. I think Z, you even mentioned that there was like one thing with CodeQL. I forget what it was, but you said that you learned something that was kind of stumping you for a little bit. So
Oh yeah,
yeah,
that was this macro invocation, and this just really comes down. I'm not sure if that's either new in CodeQL library and it just didn't have it. I was dealing with a query. I was trying to match a use of a macro, and I couldn't find a way to look up like the macro's name. Um, I didn't see this macro invocation, but perhaps I either missed it. Either way, I figured out that that exists, and that is one of the challenges with CodeKill. There's a lot of information that just isn't really documented unless you just scroll through all of their documentation, figure out what every class name is that it has, and then you maybe figure something out. It's a bit of a challenge to get up to speed on, but it has a lot of these kind of powerful primitives within it. I will also mention that today another blog post came out from ZDI. Somewhat similar, but it's static taint analysis using binary ninja, a case study of MySQL cluster vulnerabilities. So looking at MySQL cluster yet again, but using binary ninja's plugin system or analysis system to do it, which means it'll work on closed source software also.
yeah.
I haven't. Yeah. Oh, go ahead.
I'm just skimming through it briefly, and it seems like it uses some of the high-level IL stuff, and particularly the SSA, single static assignment form. So it
Yeah.
seems like it's taking advantage of the ILs for doing this analysis, which is pretty cool to see because we've always been a fan of the ILs. So
Yeah,
yeah,
that is like Binja's killer feature are their ILs, so it's
yeah.
nice to see him using that. I think most analysis things that I've seen using Binja will use the ILs as the basis of the analysis. I
Must
haven't looked at a
definitely
lot
makes
of
it a lot
them,
easier.
but that's generally what I at least recall seeing. So I at least want to shout out that it's there. I just saw this a little while before the episode, so I haven't fully read it, but just another approach at doing this taint analysis. You kind of touched on it, but it does feel like people very quickly go, I want to go find bugs, and very quickly jump into fuzzing as that next step. I'm more a fan of saying go towards manual auditing just because you learn more, but getting on the tooling side, I think taint analysis is important to play around with and not necessarily overlooked, but at the very least, not as focused upon as it could be.
And jumping a little bit on this post that you linked, it's cool that ZDI gives you both the source or like the white box perspective and the black box perspective, because depending on whatever target you're looking at, you're going to be limited to one of the two. So yeah, having a post on doing it from the binary level is really cool too, because things from that blog post can be taken and used for things like, let's say, Windows, where very often you don't have the source code for your target. So
Yeah,
great. It's really cool that we got both types of posts.
I'm waiting on somebody to work on building a CodeQL database from a black box binary.
That
There
would
has
be
been a little
awesome.
bit of research done on that I've seen. Nothing too ready for prime time yet, but it's also against the terms of using CodeQL, so there's that aspect. But people have been looking at it.
That is the one thing that's so unfortunate with CodeQL. Like, you look at it from a technology standpoint, it's so cool, and like I just love the idea of it. But then the licensing makes it so it's like you can't easily integrate it with other tools unless it's maybe like an external plugin or something. Um, it's just the legality aspect of it makes it a little bit like harder to use and get widespread adoption, which kind of sucks.
Yeah, it's a
But
lot more
that's
flexible
how
if
it
you
is.
have like GitHub Enterprise Plus. Like basically, you can pay and get CodeQL in a lot more accessible way.
Yeah, it just sucks that it's kind of gated like that a
Yeah.
little bit. All right, so we'll get into our next post, which is an exploits related blog post. It details a bug in Go Ethereum, which is Golang's a Golang EVM implementation, and a bug that would have been prevented in Rust. So, with such a provocative headline, we had to talk about it. They also detailed another bug pattern, which, to my knowledge, wasn't present in Go Ethereum, but NCC Group just wanted to cover it since it was kind of falling into that same category of a weird quirk that details with like the language details of Golang that wouldn't have been allowed with how Rust is assigned. So these bugs are of an interesting nature and are tied to the limitations of the language in a sense, or I guess the pitfalls that you can encounter, despite the memory safety guarantees that are provided by Golang. Um, and it mainly comes down to like accessing memory in mutable and unmutable states simultaneously, as well as accessing like parent scoped variables simultaneously with no synchronization, or just accessing
So
them when they should be out of scope. So
the parent scope one, I think, is a little bit more interesting than that, but let's deal with the first issue. That is the erroneous computation issue in Go Ethereum. That's the one where it's the mutable and immutable references. In Rust, this will have been prevented because you can't have like the dual reference like that, or two mutable references. Um, so that comes down, they have this example code here of return and copy. As this is an example code, this is not how it appeared in Go Ethereum. There's more code there. But the idea or the fundamental issue is just this fact that the destination and source of the to this copy could overlap. So you'd be copying into the same area that the source exists on, and that is kind of undefined. I don't think it's actually undefined in Go. They try to define a lot of things, but it doesn't return the results that you would expect at the very least. In actual like Ethereum, Go Ethereum code, that's manifested in a bit more of a complex way, but ultimately just had this copy, this call to there we go, just pulling up the code here. Had this code that basically called a set on the memory where it would end up overwriting the return value. So you have this return value up top. It's just in the interpreter EVM call, which is calling out to this data copy contract that's implemented in Go because it's just commonly used. So might as well get the performance benefit there. Has the return value, and then it ends up also calling out to the scope memory set a little bit later, which copies the return value that's given, it's passed in, uh, copies that to a new location, which is controlled by the caller, so they're able to have those two overlap, those two values overlap, such that it does this copy that has now mutated the return value when it shouldn't have. It's not expecting this set call to actually change the original return value. It's just expecting to store that elsewhere, basically, or copy it elsewhere. The fix ended up just being copy return rather than using the pointer to it. So straightforward fix. In terms of a bug, though, it's interesting how this can go. The Ethereum blockchain is a interesting location for this sort of bug to appear, because it has a very significant impact when you have this miscalculation happen and these values get changed unexpectedly. Yes, the fact that Rust would have prevented it by not even allowing the mutable and immutable references to occur is a fair call out, but I think as a bug, it's also interesting that such a subtle bug on its own could cause, significant financial damage, really.
yeah, because I
Having
mean, they kind of call out like what could happen here, and the big one is like a network split. So basically, the state could be affected in a particular way on some nodes and not others, which can cause like double spend, or it can allow double spend attacks, or you could end up just wedging the chain at a corrupt endpoint and like DOS the chain, basically, as I understand it. So yeah, I mean the impact on blockchain technology with this kind of bug that allows you to desynchronize the state is a lot larger than it would be in most other applications.
Yeah, and I thought that was a really interesting aspect to this bug, just because like in most applications, this sort of thing might result in a weird computation, but there isn't necessarily a huge security relevance to that. But in this sort of interpreter area where it's interpreting some other code, like there are some very significant things that can happen here. So I thought that aspect was just kind of intriguing, taking this pretty minimal bug into something that could do some real damage just because of context.
It's also a bug that I feel like you wouldn't encounter very often in most code bases, like because of the I guess I should say the code pattern of how, you're calling into the interpreter that could overwrite the return value unexpectedly. Like that idea is perfectly suited for something like smart contracts where you're executing like untrusted code. Whereas in most other contexts, you're probably not really going to end up in a situation like this. So yeah, the stars kind of align to allow an attack like this to exist, um, both with the impact and with just it being exploitable in this way in the first place. So I thought that was cool too.
Yeah, and also 6A in chat's mentioning I think Objective C would prevent this. I know Java, you're allowed to use one or the other, but not both. Yeah, there are other languages besides Rust that would prevent this also if they do. Like some will be more likely to copy than others. I couldn't call out which ones, but you might see this fixed in other ways also. I think they're kind of comparing because Go and Rust have this weird, like, I feel like they work in very different areas, is my feeling. Like Rust, but they kind of step on each other's toes too. Like it feels like there's this weird rivalry between the two, basically. Um, where you kind of see Go mentioned, you see Rust mentioned, you see them kind of being pitted against each other. So I think that's why they're calling it out here. But yeah, there are other ways this could have been prevented too, and other languages that don't quite lean towards the same sort of bugs. I do think it's interesting to point it out here, though, nonetheless, just because of the fact that it is one of those cases that you might not notice. And I don't know if we have much more to really say about this bug, but I do want to comment on the second bug yet. I don't know, Spectre, do you have more to say here?
Go ahead and cover the second bug. I'll kind of say what I was going to add on a little bit there, but I'll save that discussion for after we get through the other bug.
All right. So the second bug in here has to do kind of with when variables get captured when you're creating these inline or what might be referred to as anonymous functions. So the idea is within Golang, within a ton of languages, you can kind of dynamically create a function, or like, you might use that as a callback to something, kind of inline this function call, something like that. And when the variables get captured is what matters. So you'll notice this example here. It creates the increase variable, and that is a function that returns an integer. And all it does is take x, which happens to be in the parent scope, add 1 to it, and then returns the value. So then in main, you can create this function and then call it twice, and it's just going to return 1 and then return 2, which is going to increment it. That works basically how you would expect it to work. What's a little bit more interesting is when you get into the case of, so they demo it with 2 different functions being returned. I'm going to skip that example here and just go right to one of their example bugs, and that is on when the variables get captured. I think intuitively you would think they have this cleanup code here where it's just iterating over the keys. For each key, it creates this cleanup function. It just has the cleanup function array, appends to it, creates this new function, says, delete M and K, or well, delete K from M. Just delete this key from the dictionary, fine, and then later it goes and calls those. Intuitively, you would expect it to capture the value of K with the creation of the function. So that function's being created, checks what the current scope is, and captures it there. But what's actually happening is this K just gets scoped to the function itself. So I'll highlight kind of the mystery area. It gets scoped there, so what actually ends up happening is that K, across all of the functions that are created here, that are added to that cleanup function, they all end up pointing to the same K value. So the code that actually ends up running here when it calls the cleanup later is it just keeps deleting the third element, and thus doesn't clean up appropriately. So it's a really subtle bug just dealing with the fact that where that K gets scoped to, and the fact that it shares that across all of the functions created inside of this one function call. So just kind of a subtle issue that you might not be too aware of. I believe JavaScript will capture the variables at the point of creation, which is, another language where doing this sort of callback setup is common. So I mean, it's a little bit surprising that it does this. I might want to play around and see how other languages, but I thought it was an interesting bug to call out here because it does feel a little bit Go specific in how Go decided to handle this scenario of accessing the parent scope variables inside of the inline function. And just something to be aware of when you're actually looking for bugs, because this is one that, even though they don't call out a specific place where this was found as a vulnerability, I could easily see this biting someone just over this sort of issue where you think it does one thing and it's really not.
It's one of those things where it's not really intuitive reading the source code, and you kind of have to understand a bit about how Golang's escape analysis works and like how that scoping is done uh at the Go runtime level. So
Oh yeah, I guess
yeah,
sorry to interrupt you, but just add
yeah, go
on
ahead.
there, like, one of the more natural rings, like if you're coming from C, this would be well, you don't really have the same sort of inline functions, but using the parent scope does feel really weird to do, but that is something you can do in Go because the stack variables aren't really on the stack. It does its own little variable handling. So that is something that's a bit unique to Go also.
Yeah, in C, this would be like undefined behavior, or at least some of these examples would be. Yeah, Golang, because of how it does escape analysis, is kind of what allows these variables to be used, even though the way they're used isn't necessarily intuitive to the developer. So yeah, I mean, these are very interesting bug patterns. What I wanted to jump on a bit earlier with what you were saying is, yeah, I really don't understand why people want this rivalry so badly between Golang and Rust. Kind of like you, I think of them in different contexts. Rust, there's kind of a push to use it in like systems programming, kind of as like a C replacement, whereas Golang, I think, has more of a place on like the networking side of things. Um, so yeah, in my head, they're used in two different contexts. Where I would use Go, I wouldn't really use C, and where Rust kind of feels like they want to be a C replacement. Yeah, it doesn't really make sense to me very much. There are a few cases where I would use Go in like a system tooling um, perspective, like I've done before, but it's not common, and I don't think it should be common. So it's a little weird, but
Yeah,
it makes the headline interesting, I guess.
there's definitely some overlap in where you might want to use C or where you might want to use Rust versus Go. But yeah, my feeling is like they really appeal into different areas.
I think it's just that people want like memory safe languages to compete on the same like battleground, regardless of like the context of where it's used. I don't really know why, it's just the language wars, but yeah, it's something we've seen a lot with Golang and Rust.
Yeah, so real story here is use Crystal.
There
Or
you
no,
go.
Nim is the cool kid one for all the red teamers these days. Go Nim.
Go Nim. All right, so we'll get into our last topic here, which is another TIPC bug in the Linux kernel that was disclosed on the open wall mailing list. Similar circumstances to the one we covered a couple weeks ago. It's a bug that could be exploited both remotely or locally, assuming the module is loaded. And for RCE, there has to be a TIPC bearer already set up. So it's not really exploitable on default setups, but it could be exploitable in certain contexts. The bug was in the monitoring subsystem of TIPC, when it came to the handling of the member count field for domain records, which would contain the number of member nodes in the record. The TIPC mon-receive method for receiving records between pairs would take a remotely provided member count, compare that with the received record, do some sanity checks to make sure the size matched what was received, and then it'll cache that record for that information, store it on the heap, and then on a later invocation, it will copy that record into a stack buffer when another record is received. The problem is
I
that
think you
stack
have that
buffer.
slightly backwards actually. It would create, sorry, the stack buffer, I believe, is the cache one. It would copy it only to the stack for a short time because, of course, the stack is going to be gone as soon as the function returns. Um, so that mem copy onto the stack variable here, this dom buff or dom bef, sorry, or dom before, I think. Um, it's the copy into there, which is the stack variable that ends up overflowing, and that is the cache of what the current record is. So it gets like, if it gets a new first record that comes in, it's going to allocate space for it basically correctly. It does this allocation just fine. And then when it gets a second one in, if there was already something in peer domain, then it would take that value and it would copy that value out into the stack to be cached. So I think you
Yeah,
just had
and
that slightly
well,
backwards.
it gets cached in the heap beforehand to be used later on.
Well, I mean,
So
I guess I would say that's where it's supposed to be. That's not the cache copy of it, because the DOM-BEF is like the comment even mentions, like they're caching what the current record is, the one out of peer domain, onto the stack. Anyway, it's
yeah, fair
nitpicking.
enough.
Doesn't matter.
But yeah, what you were getting at with caching it back into the stack buffer, that's kind of where the issue pops up, is because the stack buffer is only 276 bytes. And that's because there's supposed to be a maximum number of records you can pass. When I looked at the source code, I believe it was 64. But the member count field is never checked against that maximum. So if you just pass more than 64 records, you exceed that 276 bytes, and you can overflow on the stack. So fairly straightforward. It is a little bit decoupled though. It's kind of a two-stage attack. You have to send two records to trigger it. So this is something that probably would be very difficult to find with like fuzzing, for example, because it requires like a previous state to be set up. So even though it is kind of a straightforward bug in the fact that they're just not checking the number of records that are being received, it is also a little bit less obvious on the fuzzing angle. So
Yeah, and it
yeah,
is. I thought this one
kind
was
of a neat scenario.
interesting because they do all this sanity checking. Like you mentioned, they check uh got the code here. They check things like if the length is enough to hold just some that has 0 records. So can it hold an empty record? Is this enough or not? They check if the length actually matches what the expected length would be with some member count, and they check if the length matches what's internal to it. So they're doing all of this sanity checking, and they're so careful to like allocate the right amount of space for it, and they'll reallocate it if the new length is larger than the old length. So they'll free it and reallocate new one. Like they do a lot of things. They're being careful with this. And then yeah, this one they just didn't check if it had more elements than what their max actually was. Like they do all of these sanity checks and miss that one. So when they do copy it onto the stack, and the stack one is just allocated with the maximum number, or the in theory maximum number of members. So it can hold enough for, I think he said 64
Yeah, it's
members. And
just an
then,
inline buffer.
yeah, it's allocated with enough space for that, which is fine in theory. Had they checked it, it's just interesting that they check all of these things and then they don't check that one internal value. Or they don't check the one that ended up mattering in this case.
Yeah. Um, I will say if you're interested in this bug, you probably should check out the actual source code of the kernel. I found the snippet they had in the advisory to be not very helpful for trying to understand the bug, because the way they have it annotated, um, it kind of leads you to think that like the dlen variable or the new dlen variable is the issue, which it kind of plays in, but it like I the snippet in here does kind of a bad job of highlighting the actual input and like the flow. So yeah, I just want to shout that out, that if you are interested in this bug, just go and read the kernel code. I would just ignore the snippet for the most part. Um,
I
but
don't know,
yeah, I
I
mean,
thought it
it's an
was fine,
interesting.
but I saw you made this comment before, like, yeah, I didn't really have too much of an issue. I did reference kernel code briefly, mostly because I just scrolled down and ignored a lot of this top part at first. And I just went to the kernel code to see what this Mondo main structure was.
Yeah, it's mainly because they call out the member count field in the vulnerability, but that gets well, we were kind of talking about taint analysis earlier. That value was tainting other values that were relevant for the vulnerability and exploiting it, but that code was excluded from the snippet. So it left me a little bit confused. I was like, wait, because I was trying to trace it from like a top down, where's the input going, and I was like, okay, I'm missing something here,
Uh,
obviously.
I feel like the issue is more just fact that it lacks the check on the member count rather than
For sure, that
the
is the
member
main
count
issue.
tainting.
But if you try to see where confirm that is the control flow of what's going on there, then it becomes more difficult with the snippet. So yeah. Anyway, interesting issue. Just because of the fact that, like I said, it's kind of this multi-stage exploitation thing. So this is something that would be hard to catch with fuzzing. I don't think they really talk about the methodology of how this was discovered, unfortunately. You don't really see that too often outside of when Project Zero tries to speculate on it. But um, yeah, I would be interested in how this one was found. But if I had to guess, it was probably manual review. So
Yeah,
yeah,
I don't
all right.
know. I mean, fuzzing could catch this.
Oh, it
It
could,
wouldn't
but
be
it would be
impossible
very
for
lucky.
fuzzing. It takes just chaining the two things, the two scenarios, which isn't impossible. Like it doesn't take a big chain of events. It's just the two things. Sends one before that's too big, and then sends another one. So I could see a fuzzer hitting it. Maybe not. Maybe you're right, but my feeling is that fuzzing could have found this too.
Yeah, I'm not saying it's impossible. I'm just saying that you would have had to have gotten lucky. Um,
Well, that's always the case with fuzzing.
Yeah, that's true. But I mean, it would have taken probably a lot of computation power to be able to reach a bug like this. But yeah, I mean, that's pure speculation. I don't know for sure. There's a chance you could run a fuzzer and find this immediately. You never know with fuzzing.
Worst
Um,
test case.
yeah, that'd be something. But yeah, I mean, bottom line, just another vulnerability in TIPC, which is an interesting target because it is a potential RCE vector. Though there are some scenario you have to hit a specific scenario. Um, Not everything is going to be exposing a TIPC client over the air or something. That's going to be quite a specific scenario. But yeah, with that said, that's pretty much all the topics we have for today. Z, unless you have anything to add on, we'll go ahead and wrap up the show.
Yeah, no shoutouts this week.
All right, cool. So, like I said, that's everything we have for this week. Thank you, everyone who tuned in. The VOD will be up on Twitch immediately or on YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join the community, follow our Twitter and join our Discord. Links for those are down below or in the chat. And we'll be back again next week on Monday for our Brownie episode and Tuesday for the Binary episode. And we'll see you all next week.